uh, I have updated the quiz results, and you can take a look. And also, sorry. And also the accuracy results of assignment 3 are released, and and they will not be updated. And you can take a look. And I also updated the accuracy results of assignment 4. And some students get -2. -2 means your program's output does not follow the requirements. And this typically because you modify the input-output behavior, and so that the evaluation program cannot understand your program's output. And you should read the instruction carefully. And here, the instruction states that you should not modify read student grades and display semester grades in the code template. Some students add some line breaks in the two functions, and doing this will cause the evaluation program cannot evaluate your program properly. So you should refer to the code template and do not modify the two functions. And I always suggest you to check your sent folder. I saw some students send a wrong file, and if you check your sent folder, you can discover the mistake, and you have chance to resend your assignment. So I always recommend you check your sent folder. And I also posted assignment 5. This is our final assignment. The deadline is 3 weeks later. And I will explain this assignment. This assignment is about to design a leaderboard. And this leaderboard tracks the top 5 scores for a game. And this leaderboard supports 4 commands: add, cut, show, and exit. Next, I will have one example to show what the leaderboard is like. Here is the leaderboard system. First, the program will output a message for the user. And then the following 5 lines are user inputs. The user can input 4 commands: add, cut, show, and exit. And if the user answers the add command, then this will follow by a score and a name. So this is like this line. So after the user input add, then the user also need to enter a score and a name. And after the user finish the input, then the leaderboard will be updated, and you can choose to show the leaderboard or not. If you want to see the leaderboard, then you can use the show command. And here we can have a test. You can download the code template. So I suggest you to download the code template. And you can start. You can run. You can run the. You can already run this code. Here I already enter this program. Then you can type show to show the leaderboard. And initially the leaderboard contains five items, and each item is anonymous, and the corresponding score is 0. So this is the initial value of the leaderboard. And after the user input, 8, 68 Lily, then your task is to implement the 8 function, so that the leaderboard becomes so after the user enter this line, then you should update the leaderboard. And then if you use the show command, then the leaderboard should like this. Because the leaderboard has only one score, so this input is in the first item, because its score is the largest one. And then if the user enter the second line, 825 EMA, then the leaderboard should be updated like this. Because 25 is smaller than 68, and so 25 should be placed in the second place. And then if the student enter another line, and the score is 25, which is the same as the previous one, then you need to check the rule. Here the rules is here. If the entered score is greater than or equal to any of the top 5 scores in the leaderboard, then it will be added to the list. And this means area will be placed before EMA, because 25 is equal to the previous one. So according to our previous rule, area will be placed in the second place, and the EMA will be placed in the third place. So after the user entered the third line, the leaderboard should become after the user enter the third lines, and the leaderboard should looks like this. And if the user enter another item, then the leaderboard should be like this. 71 is the largest. So so 71 is in the first place. So this is the first command, 8, and this assignment requires you to implement the command 8, and you should follow the rule specified by this assignment. And we also have another we also have another command, cut. So the second task is to implement the command cut. And the usage is like this. After cut, the user will input a score. And all leaderboard entries with scores less than or equal to the enter score will be removed. So here, suppose we enter 68. Then entries equal to or less than 68 will be set to 0. So here 68 and 25 will be set to 0 due to the cut command. And also the name will be modified to anonymous. So this is the second command you need to implement. Well, we can here is one remark about this system. This system does not have memory, and this means if a user insert one item, and suppose this item is not added to the leaderboard, and then this item is discarded and will not be used in the future. So this system does not have memory. After each item is processed, then this item is discarded and will not be used. You can see more examples. I also provide 2 additional examples for the add command. So you can take a look at the sample one. So after the user enter these lines, and the leaderboard should become this one. And you will see actually the leaderboard shows the largest 5 scores. So if the user enter 24 stata, and this line will not modify the leaderboard because 24 is smaller than the scores in this leaderboard. So this line will be has no effect on the leaderboard. And if the user enter 56 EMA, then this item will be added to the leaderboard. And so you should determine the position of this item. So 56 is less than 79. So EMA will be placed in the 4th place. So we can use this as an example. So now suppose the leaderboard, the current leaderboard like this, and suppose the user entered 856 EMA. Then you should modify, you should you should implement the 8 function. And the 8 function should modify the leaderboard. And the leaderboard will become so you should find the proper position for this item. So 56 should be below 79. And you modify the corresponding name. And you should also move this line down to the 5th place. So after the user enter this line, the leaderboard should become this one. Next, let's take a look at the code template. And here is the code template. You can see the main function. Inside the main function, I made 2 function calls. The default one is interactive test. This allows user to input some items. So the default one is interactive test. I also provide the non-interactive test. Non-interactive means it will perform tests automatically. You don't need to input any items. So if you run this non-interactive test, you can directly see the outputs. So this is for you. This function is for you to develop your own add and cut functions. So this is, but when you submit your assignment, you need to comment out this line, and you need to use the default interactive test, because the evaluation program will input test items to your program. So when you submit your assignment, you need to turn on the interactive test. And let's take a look at the interactive test. So inside the interactive test, we declare scores and the names. And actually, scores is, you can see the data type. The data type is an alias for a vector of integers. So here, score vector. This data type is an alias for a vector of integers. And we already learned this. This data type is a dynamic array. And also, the data type name vector is an alias for the data type, a vector of string. So the score vector will, so here the scores will contain 5 integers, and the names will contain 5 strings. And then we have a function called initialize system, and this function call will push back 5 items to the leaderboard. So here is the initialize system. We have a for loop, and here is the number of scores is set to 5. So this function will push back 5 items. Each item is with score 0, and the corresponding name is anonymous. So this function will initialize the leaderboard to contain 5 items with score 0 and anonymous, name anonymous. And then the program will output a message, and then the program will read user input, and if this input is not exit, then the program will enter the while loop, and if the command is 8, then the program will read two more inputs. The program will read 1 integer and 1 string, and the integer is stored in the variable score, and the string is stored in the variable name. So the user input will be the first 2 inputs of the 8 item function, and the third and the second inputs are a vector of scores. So names is a vector of names. So here, after the user input, the program will call the 8 item function, and you need to implement. So here you need to implement the 8 item function. So you need to modify the current leaderboard. The current leaderboard is scores and names. So you should modify scores and names according to the user input. The user input new score and the new name. So you should update the leaderboard properly according to the requirements by this assignment. And similarly, if the user input the cart command, then cin will read 1 integer from the user, and then we make a function call to the cut off item function. So the second task is to implement the cut off item function, and you will update the leaderboards. You need to update the scores and names according to the user input. The input is an integer. You should update the leaderboard according to this integer. And if the command is not the non-command, then we go to the else statement. And if the user enter exit, then this will terminate this program. Next, we will have a quiz. If you need answer paper, please raise your hand. So the first question is to determine the array size and the string length of the following character array. Uh, 30 seconds left. Then I will turn on the second question. The second question is to determine the value of name after the above statements. 30 seconds left. Then I will turn on the final question. So the third question is to determine the values in the password. Password is a static array, so you need to determine the elements in this array after the above statements. Uh, 30 seconds left. And I will turn off all the questions. If you use answer paper, please submit a paper to me. Let's see the first question. So the answer is option 4. And we need to compute the array size and the string length. And know that array size includes the null character. So below is a C string because it is enclosed by double quotes. So this is a C string. And the C string includes the null character. So you can count. We have 4 characters plus the space and plus 5 characters. And plus the \n, this means the new line escape sequence. So \n corresponds to 1 character. So here we have 11 characters, and you need to plus the null character. So the array size is 12. And when computing the string length, we will exclude the null character. So the string length is 11. And you can use the size of operator to obtain the array size. So here you can use the size of operator to obtain array size. And to obtain string length, you can make a function call to strlen. For the second question, the answer is option 3. So here you need to determine the value of name, and you will see you need to compute name1 plus double quote space and plus name2. So here we have 2 operations. We have 3 operations: assignment and the two plus, and you need to determine which operation will be carried out first. So according to the precedence rules, the first plus will be carried out first. And so first we will perform name1 plus double quote space. And you will see name1 is a C string. So here name1 is a character array. So name1 is a C string. And also the double quote is also a C string. And we know C string does not support the plus operator. So this will cause a syntax error. So for this question, the answer is option 3. So you see, so you see, for this, the error message is here. This plus does not support two C strings. So you cannot. So this plus is a binary operator plus, and this operator does not support 2 C strings. However, if you change the sequence, for example, if you move name2, so if you change the sequence of the 2 plus, if you exchange the 2 plus, here name2 is a C++ string, and you will find the syntax is legal, and you can run this code. So you see here. So here, name2 is Hilbert, and name1 is David, and the plus. So C++ string support the plus operator. So you can use plus to concatenate 2 strings. And after this operation, the return data type is still a C++ string. So you can use this C++ string to concatenate another C string. So if you exchange the order of the two plus operation, this operation is legal. For question 3, the answer is option 1. So we need to compute the elements inside this static array, and each element is assigned by this expression. So this expression is the element at the index I. So we have the dictionary C string, and at the index I, we can access each element. So the at the index 0, the element is character D. So you will perform character D minus character A. And we know this corresponds to 3, because A minus A is 0, B minus A is 1, and C minus A is 2. So D minus A is 3. And similarly, you can perform character E minus character A. So this will generate 4. And if you continue this process, you can obtain all the elements inside the password array. So for this question, the answer is option 1. And this is because each character is actually, you can treat each character as an integer, because each character has a decimal value. For example, A corresponds to 97, B corresponds to 98. But you don't need to memorize the integer value, because when you perform B minus A, you only need to compute the shift. So you don't need to memorize the ASCII value of the characters. If no questions about the quiz, then I will return to our assignment 5. We already introduced the interactive test, and next I will introduce non-interactive test. So non-interactive test allows you to test your program automatically. Similarly, we will declare a vector of scores and a vector of names, and we will initialize the leaderboard to 5 zeros and with anonymous names. And then you can make a function call to the add item or to the cut off item. And so you can make any function call you want. So here is the from our example. So here is our example. We enter for add commands, and then we enter show. So here I make the corresponding function calls, and then I make a function call to cut off item. So this corresponds to this command, cut 68. and then I display the leaderboard, which corresponds to the show command. So you can modify this function to perform different tests. So you can refer to the samples provided here. So you can generate more test inputs to test your add item and the cut off item functions. So here, I recommend do not modify the display items function, because this will, if you modify this will cause the evaluation not able to evaluate your program. Here I suggest you can use the functions provided by the vector library. This library provides some facilities like insert, erase, popback, pushback. You can use this function to implement the add item and the cut off item functions. And I also recommend you to use the add function to replace brackets, because this can help you to detect index out of range. Because index out of range will cause runtime error. And if you use the add function, this will terminate your program, so that you can quickly notice the index out of range problem. Time is up, so let's take a break for 10 minutes. Hello, let's continue our class. About assignment 5. Assignment 5 not only to let you complete the implementation of add and the cut commands. This assignment also wants you to learn how to write clean code. And so given a task like this, given the task to design a leaderboard, and this code template give you some idea how you can divide this task into many subtasks. So each subtask is a function. So this code template shows you how to design the structure of your program. So here, the overall big picture is in the interactive test, and inside the interactive test, you will call many functions like add item, cut off item, and display item. So each function has its own tasks. And the principle for each function is each function only has one purpose. So we typically do not want a function to perform too many tasks. So when design each function, usually each function only perform one task. So this will make your program this will make your program easy to understand and easy to maintain. So this code template give you an example how to write clean code. And you will also learn how to determine when to use call by reference or call by value. So we already learned this. In some functions, you need to use call by reference because you want to modify the inputs in the main function. And sometimes you just use call by value because you don't need to modify the input parameters inside this function. So when design these functions, you need to make many considerations, and you can learn some. You can learn from this code template how to write clean code. Then we will return to our slides. In the previous week, we introduced strings, and we already learned C strings and C++ strings, and we also see string input output, and we already learned the pick and the putback functions. So here is the example. Suppose the user input ABC, and the left-hand side is our program. We use cin.get. So cin.get will read character A, and the A will saved in ch1. So the value of ch1 is A, and the pointer will move to the next character B. So when you call cin.get, the pointer points to B, and the B will be saved to ch2. So the value of ch2 is B. And then if you call cin.pick, and now the pointer will point to C. So if you call cin.pick, you will get character C, and the C is assigned to ch1. So here, if you print ch1, the value of ch1 is C. But the pick will not move the pointer. So after you perform pick, the pointer still points to C. And then if you call cin.get, so cin.get will get the character pointed by C. So ch2 contains character C. So here, if you print ch2, you will have character C. And the function putback will put the input character to the string buffer. So character D will be put back to string buffer. And the pointer now will point to character D. And if you use cin.get, and you will get the pointer, the character pointed by the current pointer, which is D. So ch2 contains character D. And you can refer to the reference web page, and you can find the strings item. And under this item, here is one video. You can see this video to learn these functions. And we already see this video in the previous week. The next slide is about when you combine cin.get and when you want to read some lines. And This example is from the textbook, and I will skip this this example. The next slide is about one exercise from our textbook. So this exercise is about how to use cin.get. So first, cin.get will read one character from the user. And if this character is not the line break, then we will enter the while loop. And we also have a count. We also have a variable count. This variable is the corresponds to how many characters we read. So if you read one character, then count will be increased by 1. And here we also have the if statement. If count is if count is an even number, then we will output the character ch. So here you can run this program. The first line is user input, and the second line is the program output. And in the next slide, I show the user input in the first row. So the user input is 0 space 1 space 2 space. So the first row is the user input, and the second row is the value of count. So we see the character 0 corresponds to count 0, and the first space corresponds to 1. This is because cin.get will read every characters you entered, including the space. So for the space character, the corresponding count is 1. And this program will output the character if count is an even number. So here I highlight the character if count is even. So you see if count is even, then ch is in orange color, and which will be printed in the screen. So here we can run this program. And now suppose you enter this line. So suppose we enter this line. And then we press enter. And this line is the program output. So program will output the character when the count is an even number. So the program will output 0, 1, 2, 3. Will print this line, and which corresponds to the highlighted characters in the first row. So the highlighted characters are 0, 1, 2, 3, up to 1, and the space and the 1. So you can test this. You can test this example by yourself. And the next example is related to the previous one. And we only modify a single line. So here, this example is the same as the previous exercise. We only modify one line. We replace cin.get with cin right shift ch. So the behavior of cin is different from cin.get because cin does not read any space. So here, if we replace cin.get with this line, then this line will not read any space. So here, ch cannot be a space or cannot be a new line. And similarly, you can make a table. So here I make the same table. The first row is the user input. So the user input 0 space 1 space 2 space. So the first row is user input. And the second row is the corresponding count. So count is the number the number of characters we read. So you see here, if we read one character, then count will be increased by 1. And here you will notice space is not read. So space has no corresponding count because space will not be read by cin. So and we only print characters corresponding to when count is an even number. So here we only print highlighted ch. So here only ch with orange colors will be printed on the screen. So if you run this program and you enter the same input, the program will output 0246811. So here you will see the program will output highlighted ch. So you can run this program by yourself. So here we modify this line. And we run again. And we enter the same inputs. So here I enter the same input. Then I press enter, and you can see the program output. So the program output corresponds to the highlighted ch in the first row. So from the two examples, you can understand the behavior of cin.get and cin. At the end of our slides, I provide some question to test your knowledge about strings. So here is first question. You need to determine how many characters are present in each constants. Here, the number of characters includes the null character. If it is a C string. So the first one is not a string. It's actually only a character because it is enclosed by single quotes. So this is not a string. This is a character. So A contains only one character, and B is a C string because it is enclosed by double quotes, and we know C string includes the null character. So for B, B contains two characters, and you can use size of operator to get the number of bytes, and the number of bytes is also the number of characters. So you will see size of will return 2. So this means this array has 2 bytes, the \n and the null character. And for C, this is also a C string. This string contains 5 characters. And for D, this is also a C string. This C string contains six characters. The next question, we need to determine which declarations are equivalent, and here we have three declarations. So you need to determine which declarations are equivalent. And for this question, str1 and str2 are equivalent because their size are the same, and also their elements are the same. So str1 is equivalent to str2 because here we use double quotes, and the double quotes will include the null character. However, str3 contains only 5 elements, and str3 does not contain the null character. So the size of str3 is different from the previous 2. So only the first 2 are equivalent. For the next question, we also need to determine which declarations are equivalent. And now the situation is a bit different. Here we include the array size here, but previously we do not specify the array size. So here we set the array size to 10 for all the 3 arrays. And here you need to determine which declarations are equivalent. So now we have you can so you we already know str1 is the same as str2 because their size is the same, and also the double quote means C string, and C string includes the null character. So we know str1 is the same as str2. And now the question is whether str2 is the same as str3. If you think answer is yes, please raise your hand. If you think str2 is the same as str3, please raise your hand. Okay, very good. For this question, str2 is the same as str3 because here we need on the left hand side the character the array has 10 elements, but on the right hand side we only specify 5 elements. Then according to the C++ rule, the remaining 5 elements will be set to 0, and the 0 is equivalent to the null character. So actually str2 is the same as str3. The remaining 5 elements will be set to 0, and the 0 is the same as the null character. So this question is from the self-test exercise in our textbook. However, the answer provided by the textbook is wrong. So if you see the textbook, you will find the answer in the textbook is wrong. This is the last page. We need to determine which declarations are equivalent. So here you can find str1 is equivalent to str2, and also str1 is the same as str4 because the array size is 6. Hello contains 5 characters and plus the null character, so the array size is 6. And the str4 is the same as str5, and it's the same as str6. So here we know str1, str2, str4, str5, str6 are equivalent declarations. Because their array size are the same, and also their elements are also the same. And str3 only contains 5 elements, so the array size of str3 is 5. And str7, str8, str9 have different array size. The array size is 7. And we have finished this chapter, and next we will go to the next chapter. So the next chapter is about sorting. So we already learned how to sort integers. In this chapter, we will learn how to sort a vector of strings. And first, we will learn what is string comparison. And actually, you can compare 2 strings. And we already learned this from the previous chapter. So if we want to compare two string, for compare two C string, you can use strcmp, and strcmp returns 0 if two inputs are the same, and returns a negative value if the first input is less than the second input. Otherwise, return a positive value. So you can use strcmp to compare two C strings. For C++ string, it is even easier. You can use the comparison operator to directly compare two C++ string. So here we can directly compare two C++ string. And the result is so the result is in dictionary order. So A is smaller than B, B is smaller than C. So the comparison result is according to dictionary order. And so you see, you can use the comparison operator for C strings, but this will not give you the desired result because because we know E is larger than D in dictionary order. However, if you use comparison operator, this generates true. So this is not what we want. So you cannot use the comparison operator to compare two C strings. If you want to compare C strings, you need to use strcmp. So here, according to its manual, here its manual, if the first one is greater than the second input, it will return a positive value. So this one will return a positive value because the first input is larger than the second one. So if the first one is smaller than the second one, then this function will return negative. So if we want to compare two C strings, we need to call the strcmp function. And this function is defined in the C string library. And for C++ string, it is easier. You can directly use the comparison operator. So you see here we can directly compare to C++ strings using the comparison operator. So Bill is smaller than David, so this operation, this expression generates true. And if you modify the first one to Emma, and Emma is not less than David, so this expression will generate false. And the false is 0. So you see, for C++ string, it is more intuitive than C string because we can directly use the comparison operator. And here I include the parentheses. If you remove the parentheses, then we will have a problem because the precedence of this left shift operator has higher precedence than the less than operator. So this operator will be carried out first. And this is fine. This will output CPP str1. However, we have a problem. After this expression is carried out, it will return a cout object. And the cout does not support the less than operator. So you will see this error message. This is due to the precedence of the operators. So here we need to use the parentheses to enforce the less than operator will be carried out first. And then we can perform sorting. Suppose we have a vector of strings. So here we have a vector of strings. And this is similar to a vector of integers, except that each element is a string. Actually, when you perform this, this is a C string. When you perform this assignment, the C string will convert it to a C++ string by the constructor. And then we can use sort to sort a vector of string. And this is similar to what we learned. We already know you can use sort to sort a vector of integers. And now you can do this for a vector of strings. And similarly, you can specify the range you want to sort. Suppose we want to sort the whole vectors. So here I just print each element in this vector. We need to include a library. So here I use the for loop to print each element in this vector. Then we can start to perform sorting. It's better to write a function, so we can reuse the code. So here I write a function to reuse to print the vector. So here I write a function print vector, and you see you just copy the for loop inside this definition, and you need to determine the data type. So the input data type is a vector of strings. Here I use call by reference for efficiency. So I also add the const modifier because I will not modify the vector inside this function. So this is very typical declaration. Then after sorting, sorting will modify this vector. So after sorting, if you print a vector, it will be sorted in ascending order. We also need to include the algorithm library in order to use sort. So here the first line is the original vector, and the second line is the sorted vector. You see the sorting result is in ascending order from A to Z. It is in alphabetical order. So the comparison is according to dictionary order. So here the sort function performs comparison according to the dictionary order. And here we have other choice. Suppose you only want to sort the first four elements. So here you only need to modify the range. So now suppose you only want to sort the first four elements. So here we modify the second input. So you see here only the first four elements are sorted because we only specify the range only contains the first four elements, and the remaining two elements remains the same. And actually, you can customize your sorting. So I will introduce another version of sort function. So what we use is the default version, and actually sort have another version. This is known as function overloading. So you can look up the manual of the sort function. So here is the declaration of the sort function. We have two declarations. The first one is the default version, and for this version we have two inputs. The two inputs are iterators specify the range we want to sort. The second version is a customized version. You can customize the sorting. So this version has three inputs. The first two inputs are iterators, which are the same as the default version. However, this version has the third input. The third input is a comparison function. So the third input, you need to supply a function. The function needs to compare, can be used to compare two elements inside this vector. So I will introduce the second version. So here, I use the customized version. I want to customize my sorting. So here you need to provide a function like this. So here is we call the comparison function. And I define this comparison function in the next page. So here you can define the comparison function as this. So this comparison function compares two elements in this vector. So the inputs are array elements, and each element is a string. So here, the two inputs are strings. So you can see so the two inputs are actually any two elements in the vector. So here we use call by reference. This is for efficiency, and we also add the constant modifier because we will not modify the inputs inside this function. And notice about the return value. The return value is a Boolean value. It's either true or false. So the comparison is either true or false. So we here, this function will return a Boolean value. And then you need to implement this compare function according to your needs. Here I implement the default one. The default one is we compare str1 with str2 using the comparison operator. This is the default behavior. And this version will generate true if str1 is less than str2. And this version generates false if the comparison is not satisfied. So now we can implement this function. So you see, sorry. Sorry. So we see here, our customized version is the same as the default version. So you see their results, their sorting results are the same. And now you can modify the behavior. The suppose you want to customize, you want to sort in descending order, then you can modify the return value. So if we want descending order, then you just replace you just replace less than with greater than. Then you can obtain descending sorting results. So here you see the third line is for our customized sorting results. We customize the comparison function. And this function compares two elements, two strings according to this operation. So you will see the results is in descending order. I think the time is up, so we can take a break for 10 minutes. Hello. Let's continue our class. We talk about how to customize your sorting by the comparison function. And here we only perform comparison by dictionary order. And actually you have other choice. For example, you can perform comparison by string length. So to do this, you can define your own comparison function for string length. So now suppose we want to perform sorting according to string length. And now we need to define the comparison function. The inputs are the same. So the two inputs are two elements in the vectors. So also the return data type is a Boolean value. So now here we need to implement the comparison. And actually, so you need to modify this expression. So actually, I think this is straightforward. We just compare size. So previously we directly compare two strings, and here we compare the string size. And so we can test this function. So here is the comparison result, and this is according to string length, because here we replace the comparison expression according to string length. So here you see both Bill and Alex. The string lengths are 4. So both Bill and Alex are in the beginning of this vector, and then follows by camel, which has 5 characters, and Zitella has 7 characters, and this Yolanda also have 7 vectors, 7 characters. And Alexander contains 9 characters. So this is according to string length. So here we can provide our own comparison function. Here you can use, or you can also use length. Length is the same as size. And next, let's talk about the sorting behavior. And now suppose we want to sort this integer array. And for this integer array, we have 2 repeated values, 5. We have 2 5 in this integer array. Now you will have 2 sorting results. The first one is this one maintains the relative order. So we know 5 star is after 5. So for this sorting result, 5 star is after 5. So the sorting result maintains the relative order of 5 and the 5 star. However, you might have another sorting result like this. 5 star is before 5. So for this one, the relative order is not maintained. But both are correct sorting results. So both are correct if you because both sorting results are in ascending order, and both results are correct. And sometimes we want to maintain the relative results. Sometimes for some tasks, you want to maintain the relative order. If the sorting algorithm maintains the relative order, then this type of sorting is called stable sorting. Otherwise, if the relative order cannot be guaranteed, then this type of sorting is called unstable sorting. Then we have a problem. We have one question. The sort we used is stable sort or unstable sort. So we already use sort. And do you know this sort is stable or unstable? If you think this sort is stable, please raise your hand. If you think it is unstable, please raise your hand. Oh, okay. Actually, this is unstable. It cannot guarantee the relative order after sorting. If you want to use stable sort, then in C++ we have So if you want to guarantee the relative order after sorting, then you can use stable sort. This is also defined in the algorithm library. And the usage is the same as sort. So here below I have one example to demonstrate stable sorting vs unstable sorting. So here I have one example. So here I define a data type. So we will learn in the next chapter. We will learn we can define our own data type. So suppose I define a data type student. So I use a structure to define a data type student, and this data type contains two members. The first member is name, which is a string. The second member is score, which is an integer. Then I can use this data type to declare a static array. So you can use this data type to declare an array of 4 elements. So we already use this. This is like a static array. So this is a static array. We use this data type to declare an array of 4 elements. And you can start to assign each element. So for the element at the index 0, you can specify the name to be Alice, and its score is 90. And you can specify the second element, its name is Bob, and the corresponding score is 75. So you can specify each element. Now suppose we want to perform sorting. You want to sort this static array. And now you have two choices. You can perform sorting according to student's name or according to student's score. So you have two choice. And then you can customize the choice by a comparison function. So here, suppose we want to perform comparison by score, then you can implement a comparison function like this. So the two inputs are the two elements in this array. So each element is of data type student. And then here we perform comparison to A dot score and B dot score, because we want to compare by scores. And then you can print the sorted results. The sorted results is in the next page. So in the next page, you can print the sorted results. So here we can try to run this program. So here I define this data type student, and this data type has two members, and we also need a function to print the array. So here I modify this function to print the array. And we need to modify the input. So now the input is an array of student. So here we need to modify this this function declaration. Here I don't use call by reference, because for static array it is already call by reference, so I don't need to add the ampersand operator. So we need to send array size, because for static array, we need to send array size, and we can only use brackets, because static array does not support add function. So here is the print array function. So here I need to specify the member. So suppose I want to print name or score. So you need to specify the member. So now we can print the elements inside this array. So the first element is Alice, and its score is 90. The second element is Bob, and its score is 75. Now suppose we want to perform sorting. And now we have to define our own comparison function. So you need to modify the data type. So the data type is student. And we perform comparison according to score. So here we need to call score. So you see here, I perform sorting according to comparison score function, and you will see the sorting result is according to scores in ascending order. So you see here 70 the first set. So you see the first element is Bob 75. Because 75 is smaller than 90. And you can also perform comparison according to names. So you can define another comparison function. So this is according to the data type So here this data type contains string, so we can use this member. So here we compare the two members. So now if we perform sorting according to names, and you will see here is the sorting results. The sorting result is Alice, Bob, Charlie, and David. So this is the same as the original one. You can modify the origin array. So here I switch David and Charlie in the original array, and after sorting, you can see the sorting is according to alphabetical order. That is the dictionary order. So for this example, you will you might have a problem here, because when you perform sorting according to scores, suppose you perform sorting according to scores, we have repeated scores. For example, 90 appears twice, and the 75 appears twice. And the relative order of repeated scores cannot be guaranteed. So the outputs might be like this. So the outputs cannot guarantee the relative order. In our original array, Bob is in front of David. But after sorting, you see David is before Bob. They are of the same score, but their order is switched. So this is due to unstable sorting. However, if you use stable sorting, the result is unique. The relative order is guaranteed. So Bob is before David, and Alice is before Charlie. So if you use stable sorting, you can guarantee the relative order. However, if you use this sorting, this is unstable sort. So for repeated values, you cannot guarantee the order after sorting. And we have finished this chapter. Actually, the textbook does not have this chapter. This is introduced by myself. So I want to emphasize the usage of sorting. And our next chapter is structures and classes. And in this chapter, we will learn how to define our own data type. The motivation to define our own data types is very intuitive. Suppose let's consider our assignment 5. In assignment 5, we need to design design a leaderboard. This leaderboard contains both scores and names. And if you want to deal with this leaderboard, you need to process scores and names separately. This is inconvenient because you need to send the two inputs. However, if you can define if we can define our own data type like this, if you can define our own data type, then you only need to send one vector to a function. So if you can define if we can define our own data type, you only need to send one input to this function. So for example, if we can define our own data type, you can make the design more compact. I will briefly to show how to refactor this program. So here, if you define your own data type, it is typically like this. Here, I define my own data type, player. Player is a data type. And this data type contains two members, score and the name. And then I can use vector to create a dynamic array, to create a vector of players. So this is a container. And then I will initialize this vector by the same function call. And you see the function input is a vector of players. And you will see the function call is the design of this function is more elegant because I only need to send one input. However, if you do not define your own data type, you need to send scores and names separately. So if you can define your own data type properly, you can refactor your code more elegantly. So let's see the slides. In this chapter, we will learn structures, and this is from the C programming language. And the second part is about classes. The C programming language does not have class. So class is introduced by C++. So structures only contains member data. And C classes, besides member data, it also contains member functions. The third part is about object-oriented programming. This is a kind of programming paradigm. Some programmers use this paradigm to develop their own software. And so the third part, we will introduce object-oriented programming. And this is the reason why the creator of C++ wants to create C++, because he wants the C programming language to support OOP. So the creator of C++ introduced the class syntax to support object-oriented programming. So the first is how we can define our own data type. We can use the structure keyword. And after structure, you can choose any name you want. So you can, and typically the first word is in uppercase. And we use this convention for defining data type. So we usually let the first letter be in uppercase. And then it's followed by a pair of braces. And we use a semicolon to terminate the definition of this structure. And inside the braces, you can declare any variables you want. So you can declare variables here. This is according to your needs. So for example, I want to define a data type automobile. And this data types will describe the features of a car. So I want to know the year of a car, the fabric year of a car, and I want to know how many doors a car has, and I also want to know the horsepower. So you can define this declare these variables inside this structure. And when you define this structure, no memory is allocated. Only when you declare variables, memory is allocated. So to use this structure is very straightforward. So you use this data type to declare variables, and you use dot operator to access each member. So for each car 1, we have 3 members. We have year, doors, and horsepower. So you can use the dot operator to set the value of each member. So this is very straightforward, and the other programming language use similar syntax. And you can also choose to simultaneously define a structure and also declare a variable. For example, after the braces, you can declare a variable car1. So this combines structure definition and the declaration of a structure variable. But actually, we do not like this style because this style is combines two scenes into one statement. We do not prefer this style because this is not easy to read. Just when you combine two scenes into single line, this makes your code difficult to read. So usually we perform the previous style. We want to separate structure definition and variable declaration. We want to separate the two texts because this makes your code more readable. And here, this slide is about structure assignment. You can suppose we declare two variables, car1 and car2, and they are of data type automobile. And you can assign car1 to car2, and this is equivalent to you individually assign each members. This is equivalent to you assign each element of car1 to corresponding element of car2. So this is very convenient because you only perform one assignment, but actually it automatically perform assignment for each element, for each member. The next slide is about how you can send a structure as function arguments. We similar to built-in data types, we have two choices. The first choice is call by value, so you can use call by value. And the second choice is call by reference, so you can add the ampersand operator. So this is call by reference. And if you do not modify arguments inside the implementation, you can add the const modifier to protect from accidentally modify this input. So we have two mechanisms to send structures as function arguments. So this is the same as built-in data types. And we usually use the first one because first one is more memory efficient. The second one is we typically do not use method 2 because you need to copy the entire structure. And we can do an experiment here. So here I use this structure to. So here I declare a vector of students, and I call the resize function. So this resize will adjust the size to 10. So this vector will has 10 elements. So its size is 10. And if you print its size, you will find its size is 24 bytes. This means if you want to, if you use call by value, then you need to copy 24 bytes for this vector. So the next one, if you use call by reference, this means you send the memory address of this vector. So here, this is equivalent to send the memory address. So here I use the ampersand operator to obtain the memory address of this vector. And you can see the size. The size of this memory address is only 8 bytes. So you will see using call by reference is more memory efficient than call by value. Because if you use call by value, you need to copy 24 bytes. And if you use call by reference, you only need to copy 8 bytes of memory address. So this is the reason why we usually use method 1. When we want to send a structure or when we want to send a class, we usually use call by reference. You can do one more experiment. For example, you adjust the vector size. Also here the vector size is the same, even if you adjust the array size to 100. In fact, you can use structures inside structures, and this is known as hierarchical structures. So for example, I want to define a structure, personal info, and this structure contains height and weight, and also the birthday. For birthday, we have no such built-in data type. So you need to define another structure for deal with birthday. So here we define another structure, date, and this structure contains year, month, and day as member data. So you can use person info to declare a variable person1, and you can use person1 dot birthday to access the birthday member. And because birthday is also a structure, so you can also use the second dot operator to access the member of the date structure. So you can use a chain of dot operator to access hierarchical structures. And this is very common for object-oriented programming. So you will see a chain of dot operators to access member data or member functions. The next slide is about structure initialization, and this is very similar to array initialization. We use a pair of braces to initialize an array. So you can also use a pair of braces to initialize a structure. So here we have 3 members. And if you only specify the first 2 members, and the remaining member is unspecified, and the rule is the same. The unspecified members will be set to 0. So if you only set the first member, the remaining the unspecified members will be set to 0. However, if you do not perform initialization, if you do not use assignment to perform initialization, and actually it's the initial value will be unknown. So this is the same as built-in data types. Built-in data types, if you do not initialize variables, their values are unknown. So you see here, I do not initialize this structure. You see some random value. So here I only specify the first member. And you see the remaining, the unspecified member is set to 0. I think time is up, so the class can be dismissed.